This video is being done to show you how to create the axle support for the caster assembly, the first project in the SolidWorks class, the parametric modeling class with SolidWorks. We're looking at SolidWorks 2010 right here. So I'm going to start by creating a new file. It's going to be a part file. First thing I need to do is change the units. So I'm going to go to Tools. You can't see it on this video because it scrolls off the screen, but I'm going down to the Options. And I'm going to pick under Document Properties, Units, and change the units to millimeters. I do that, I'm going to pick OK. That's also off the screen, but you know how you're going to pick OK. So now I'm going to start by sketching. Once again, I say once again because I've been making a number of these, but you're going to start with a center line, which is a construction line. And I'm going to start this one on the right side plane. Right side plane, I'm going to start by drawing a construction center line that goes right down through the origin. And you notice when I do that it's black because it's constrained in its location by going through the origin. Sorry about that. Get that out of the way. I'm just going to go and take a look at this from the right hand side so it looks like that. Now I'm going to use the origin as a starting point for this. I'm going to have it at the top. And I'll do that by starting a line. And I'm going to snap to the origin, go to the left, and I'm going to draw half of the part. That's why I have that center line in there. So the overall width of this axle support is 82 millimeters. So I'll go over to about 41 millimeters. Then I'm going to go down about 10 millimeters, come down at an angle, and now I'm going to go and hover back over the end of that line, and you notice what happens is I start to get an arc. Well, if I go to the center line and I get both tracking lines lined up so that the center of that arc is right on the center line, it is right there, left click. Now I've created an arc whose center is on the center line itself. Now what I'm going to do is to mirror all these objects about the center line and then accept that. I'm doing that first so that now I can go back in and smart dimension. And the first dimension I'm going to put on here will be the dimension from the top down to that corner, which should be 10 millimeters. Now I'm going to put dimension from that corner to the center because that's what you're given in the textbook. Do that one again. Smart dimension from the top of this to that corner. It's going to be 10. Say OK. Now I'm going to do another dimension from the point that I just picked, that corner, to the center of the arc. Bring that over here like that, and the distance is 48. I do 48 and it pushes it down. You'll notice that because I drew the arc the way I did it, it's already automatically tangent. Now let's go ahead and dimension the arc. That has a radius of 19. Comes out like that. Now we're going to do the width smart dimension, so I'll go from that edge to that edge. Put it up here. 82 is the overall width of the part. And then it looks like that. Now you'll notice this is fully defined. And one of the reasons when I did the width dimension I went to the line instead of the end point is so that those lines remain vertical. They are constrained to being vertical anyway. So that's my basic shape. I'm going to come over here to extruded. And I want to extrude this in one direction or the other. Just because of the way I envision setting this up, I'm going to flip the direction it's going in. It's going to be a blind extrusion, and since the thickness of this is 10 millimeters, which happens to be what's there, I'm just going to accept that the way it is. Now what this does for me is it gives me an origin that's right dead center on one edge. You see that's where it is right there. And that's where I want it. Now I'm going to build the part that comes out on that surface right there. So my next sketch is going to be on that surface. So that's where I'm going to be sketching right now. And I'm going to start by creating a rectangle using the corner method. And I'll go to that corner here. And I'll go down and go to that corner right there. You notice it's black automatically. It's fully defined because I have constrained it to those 2 points on the original axle support. And that's good because if the size of this changes, then the size of that will change as well. I'm going to go back over to Features, Extruded Boss. I want that to come out. The overall width of that is 38 minus 10 is 28, so we'll change that to 28. Pick OK. Now you notice we've got the basic shape of this. Now there's some rounded corners to deal with here, but I also have a raised boss to put right there. So go back to sketch. I'm going to do a circle. There's my surface. I want it to be centered right here, and I want to bring that over so that it snaps to this. Once again, it's black, fully defined. I don't have to size it. It's just simply going to be driven by the size of that radius right there. Come over to extrude. I'm going to change it from 28 to 2, just how far out that comes. So now I've got the raised boss area right there. Now there's a few other features on here, of course, that I think you can probably do without any trouble. I'm going to put a hole in this. Then you're going to put fillets on those corners. And I'll have a separate video that shows you how to go about filleting this whole thing, because this is a complex filleting operation. You're going to have to do a couple of different things that are a little unusual. So we'll finish this off by punching a hole down through here, draw on that surface, put in the hole, smart dimension it, bring it out here. The size of that hole is 22 millimeters. Bring it through like that, fully defined. Go back to features. We'll do an extruded cut this time. Instead of being blind, I'll go up to next, which takes it all the way to the next surface. Now I have the hole through there. We can now, in the feature mode, go over here to fillet. Say I want to fillet that corner and that corner. They're going to have the same size. We'll do a full preview so we can see them. They're going to be the same size, and the size of those fillets, 12. Now I want to put a couple more holes in there. We can use a hole wizard on this one. Go to the hole wizard and position. What we're going to do is put our holes right on this surface right there. So I'm going to pick the surface. One thing that you can't do with hole wizard, unfortunately, though, is you can't snap to the center of one of those while you're placing. So the minute I pick this, it's going to decide to put a hole in there, which means then we're going to have to constrain that hole. We can constrain that hole by adding a relation. So we want to add a relationship between that and that edge right there, and the relationship we want to add is concentricity. Goes through like so. Now we can go back after hole position. We can go over to the hole type and have it be a through hole that's not. Actually, I'm just noticing that it's really a spot-faced hole from the bottom, although the spot face is not a specific depth. So let's do this. We'll go ahead and do the hole, and we'll come over here. ANSI metric. We're going to use a specific size, and the hole size in this particular case is a diameter of 11. So we're just going to go ahead and pick the 11. And down where it says blind, we'll change that to up to next as well. Comes through like that, and then we'll go ahead and just mirror that hole so it comes to the other side as well. Could add something to it, actually. We could go up here, and under positions, we can add another position here if we wanted to. That other position would track right off of this one. Let's see if we can track off of that. Can we? Okay, well, we'll put it right there. And once again, we'll go ahead and add a relation. And we'll say we want the relationship between that point right there and that arc to be concentric. So now we have two holes, and the holes are concentric. Now we also do have a little spot face down here, and it could be considered a counterbore or a spot face. Just to give you a different technique for putting a hole in, we'll use a circle. We'll sketch here. I'll go to the center. I'll bring it outside like this. We will give it a dimension. Dimension in this particular case is going to be 20 millimeters. Now that's fully defined. We'll go back over here. We'll do an extruded. We'll do an extruded cut, not an extruded boss, so it goes up in. And we'll go 2 millimeters. That's about right for what we want on that. And now in this particular case, we'll take that feature and we'll mirror it so it's on the other side. So if I say I want to mirror, my mirror line is going to be a plane, and it's going to be the front plane. The feature to mirror is going to be that cut extrude. Pick OK. Now I've got the whole thing modeled except for the fillet. In the interest of keeping these videos under 10 minutes each, we'll deal with the fillet in a separate video.